Welcome physics students. In the last video, we began our study of kinematics. Kinematics is a mathematical study of motion or mathematical cataloging, like keeping a record. So within the topic of kinematics, there are three ideas, three ways we can catalog an object's motion mathematically. There's the displacement, which is how far something is and in what direction it is from its starting point. You describe the displacement for all times and you have a mathematical record of the object's motion. Velocity, how fast something is moving and in what direction. If you specify that for a certain amount of time for a motion, that's also a complete way to catalog the motion of something. And finally, acceleration, how rapidly something's speeding up or slowing down or turning. If you state that, that also catalogs the motion. But you should get a sense that these things are somehow related to each other. For example, if I'm in an old clunker, like I mentioned in the last video, 30 years old, it barely runs, it sputters, and I floor the gas pedal so I make a small acceleration. The speedometer rises slowly because the car has a poor acceleration. Someone else is in a Lamborghini, they've pressed the gas pedal down and it takes off like a bullet. If we wait a certain amount of time, say 5 seconds later, everyone could say, you know, the Lamborghini's probably farther along on the road. In other words, the displacement is affected by the acceleration. So there must be some kind of way from acceleration to figure out the displacement. And the velocity, the Lamborghini's going faster after a certain amount of time. So that's the topic for today. The relationship among all these kinematic ideas. And the relationship is, not surprisingly, stated with formulas. So let me step aside and give you a chance to jot this down. Okay, so first of all, this is the final velocity of something is equal to its original velocity plus the acceleration times the time over which it accelerated. So this tells us the velocity if we know the acceleration. This formula, the displacement, is v initial t plus 1/2 at squared. In other words, if you have an object and it's accelerating for some amount of time, and you know its initial speed, you can plug it in and find out where it is in terms of its starting point. And this formula relates the two velocities, the velocity at the beginning of a motion and at the end, acceleration and distance. Okay, so you've got these in your notebook, but what I want you to do, as always, you know, you write things down in your notes to keep things complete, but I want you to practice finding this stuff on the reference table, which is how you solve Regents problems. So this is the front cover, page 6 on the back. Remember I said this is, we'll spend about half the year on this page. So right here near the top, you could see the formulas that we learned yesterday. V equals d over t, A equals delta v over t. So they're there. But also the three formulas that we just wrote down in your notes, they are right here, right? You could see them. So you should always be able to go back, and you should make it a habit to go back into the reference table to find the formulas, okay? All right, so what I'm going to do is I'm going to spend the rest of this video going over some example problems to show you the technique of how to use these formulas. First one right here, example 1. A car accelerates from rest at 5 meters per second squared for 8 seconds. The first thing we're going to do is determine how fast it's going. Okay? Now let me just say a lot of students have difficulty applying these formulas because they don't necessarily see which one to use. So I'm going to show you a technique that is kind of foolproof, and you should do this especially in the beginning. So what I would recommend is you jot down all the information the problem gave you. For example, the car accelerates at 5 meters per second squared. So I'll write A equals 5 meters per second squared. Now, this from rest, okay? What does that mean? Well, think about when you're resting, you're like in bed or on a chair or something. So if you accelerate from rest, you began like in a chair. Like at rest means not moving. So that's very common. They don't say, oh, initially the object wasn't moving. They very seldom say that in the region. They say from rest, and you've got to know, oh, I know what that means. VI equals 0. Okay? You could put 0 meters per second, not necessary. 0 and 0 meters per second, same thing. Okay? And 8 seconds, you should know that means the time. 8 seconds. Now, how fast is it going? Well, think about this. It's 8 seconds has gone by. So that's now like after, which is the velocity final. So that's what we're looking for. And I put velocity final, question mark. So now we go back to our formulas and we look for a formula that has these 4 variables in it. Okay, so you could see it's not this one and it's not this one because this doesn't have final velocity, so that's out. This one has final velocity, but we don't know the displacement and we can't plug in time here. So it's this one. This has all the variables that we laid out. So see how it's foolproof? Which formula you write down and then boom, you see which formula it is by what matches what we have. So as I've mentioned throughout, what you have to do is write down the formula first. V final equals V initial plus AT. Okay? So, I need to make some room. And I plug in the variables in question. So V final is the unknown. I'll leave it, well, maybe I'll do V final equals V initial, which is 0, plus 8 meters per second squared. No, 8 seconds. 5 meters per second squared times 8 seconds. Multiply that out, and I get 40 meters per second. Very fast. That's speeding. You would get a ticket for that. Okay, so that's part A. Okay. Part B. Okay, so no capital here because we're continuing with the sentence. Determine B, how far it traveled. Okay, so now we're looking for how far D. Okay, and we still have that original information. We have acceleration, VI, T, and now we're looking for the displacement, how far it's traveled. So we go back to our reference tables. By the way, I would recommend that you have this reference table, your reference table out while you're doing these problems so you can look also. So you look and see that basically it's not this formula that we just used because there's no distance in it. This is the proper formula, okay? It has VI, T, and acceleration and time, which is what we have in our formula. This one doesn't have time in it. So it's the second one, D equals VIT plus 1/2 AT squared. So once again, I've got to write the formula out. D equals VIT plus 1/2 AT squared. Always, right? Otherwise you lose a point. You plug in your initial speed, 0 times 8 seconds. Plus 1/2. The acceleration is 5. Plus 8.0 seconds squared. Okay? So this part of the formula is 0. So we just have 1/2 AT squared, which is 160 meters, I believe. Just doing it in my head. Maybe I made a mistake. I don't know. but you would crunch it on your calculator. Okay. Let me pause the video to allow you to jot this down. Okay, so again, formula, numbers plugged in with all the units. You leave something like this off, you're going to get a 1 out of 2. Terrible, right? Terrible, terrible, but we got to have that in there. And then you crunch out your number, and you got to have the meters. Again, 1 out of 2, right? So we don't want to leave units off in the answer either. Now, another thing I want to point out before I go on to part C is that sometimes it's perfectly acceptable to do this. You knew the V initial was 0. So if you wanted to just write the formula like this, because you know 0 times time is 0, so you just write d equals 1/2 at squared. And then when you plug in this, okay? Might seem lazy, and Regents is mean. They always want to take points off. Maybe they're going to take points. No, that's perfectly fine. So leave the part of the formula that's 0 out of the formula, out of the calculation. Full credit here, okay? All right, let's do one more part here. So the car is moving at 40 meters per second. Okay, there is the question. The car is now moving 40 meters a second. It got going, it's racing along, and then for whatever reason you jam on the brakes and you're maybe skidding to a stop or something. You want to know how far did it go to stop, okay? So we follow that process again. We've got to think about what formula we need, and the only way, the sure way to do it is to write out the variables. So we've got now the car moving 40, and then it's going to brake. So now that 40 isn't the final velocity. It's now the initial. What happens the moment you begin braking? Oh, not 20, 40. Okay. And then it says there's an acceleration of -8. By the way, sometimes they don't tell you the negative. You have to know that it's negative. They say, oh, it's decelerating at 8, and you would say, well, wait a minute, positive 40. The only way for it to slow down is with a negative acceleration. So my velocity could go down to 32 after 1 second, not up to 48, right? If it were positive, that means I'd go 40 plus another 8, I go to 48. Well, no, we're not doing that. We're slowing down. So we'd have to have an opposite sign for the acceleration. We don't have a time, right? The time was for speeding up, okay? So we don't know how long this thing is braking for. And we're looking for how far, but before I do that, there's something else that we know, and that's that the car came to a rest. So like before, we were from rest, that was 0. If we go to rest, that's the final velocity of being at rest stopped 0. So final velocity. See how these problems could be tricky? You've got to decode all these words and realize what they're saying in terms of the numbers, the variables in kinematics, which is what kinematics is all about, getting all these concepts into numbers and formulas. Okay, now, how far does it travel in coming to a rest? How far you should recognize that as a displacement. So I laid the variables out now, and now I go looking for a formula. I don't just guess. So get close here. So here we are again with our formulas. right? And is it the top one? Well, the problem with that, it has no distance in it. That's not going to help us. We're looking for a distance. This one has a distance, but we don't know anything about time, right? This second formula has time in it. We don't have time. The third formula has no time. It has the two velocities, initial and final, acceleration and distance. And if you look at what we have here, that's what we've got. Okay? So let me write out the formula again, right? I don't want to lose my point, right? So I got to do V final squared equals V initial squared plus 2AD. Okay? Okay, let me pause to give you a chance to jot this down. Okay, let's continue. I'm going to plug in my numbers now with all the units. So V final is 0. You could put 0 meters per second squared, but it's not necessary. 0 times meters per second is still 0. I'll throw it in there. Why not? You know, maybe we want to be extra careful in case, you know, someone's feeling mean when they're grading, right? Not me, never, right? So now the V initial is 40. To acceleration -8. Uh-oh. Need a little more space here. And the distance is what we're looking for, right? So this is 1600. And this is -16 d. So I could add the 16d to the other side and have 16d equals 1600. Okay? So divide both sides by 16. Oh, I got lucky. I forgot my calculator upstairs by my desk, so, but this is nice and easy, so I'm not in trouble. I could do that. 1600 divided by 16. Okay, so there it is, the stopping distance. I'll pause to give you a chance to jot this down. Oh, and maybe this too. Okay. All right, so I'll stop there. I think that's good enough for examples. Remember, have your reference table out while you're doing the problems, okay, to the back page tonight. And, you know, the homework, you know, basically you're doing these and just do your best to try and solve these problems using the technique. Lay out the variables, find the formula, plug the numbers in with units, and solve. Okay, so that's the idea today. All those displacement, velocity, acceleration, all related with formulas. That's what we learned today. I'll see you in the next physics video.